This video is for homework 10 question 1. First one, Poisson process. It is the number n t1, t2 of the points ti and the interval of t1 to t2 of length t equals t2 minus t1 is a Poisson random variable with parameter lambda t. So the probability of n t1 t2 equal to k equals e of negative lambda t's power times lambda t to the kth power over k. The mean of Poisson process is lambda t, which is a linear function of t. It matches our common sense. The longer time we wait for, the expected number of buses is larger. The autocorrelation function contains the term minimum of t1 and of t in t2, which comes from the property of independent increments. Second, Poisson increment process. It is defined as yt equals xt plus sigma minus xt over sigma, where xt is Poisson process. It defines Poisson impulse process. The expression of autocorrelation is a triangle with area lambda, which is independent of sigma. When sigma goes to 0, the triangle becomes an impulse with area lambda. Third one, point impulse process. It is ct equals dxt over dt, where xt is Poisson process. The process ct minus lambda has 0 mean, and autocorrelation rt1 t2 equals lambda times delta of t1 t2. That is ct minus lambda is a white noise. Next, semi-random telegraph signal. Xt is defined based on Poisson points. The number n of t1, t2 of the points ti in interval t1, t2 of length t equals t2 minus t1 is a Poisson random variable with parameter lambda t. So the probability of n t1 t2 equals k equals e of negative lambda t power, then times lambda t kth power over k. Xt equals to 1 when k is even, and equals negative 1, k is odd. The probability of xt equals 1 is not 1 over 2 because we start with positive 1. The probability of xt equals 1 should be a little higher than half. It equals 1 minus e of negative 2 times lambda t's power over 2. Goes to half when t goes to infinite, which matches our expectation. E of xt equals e to the negative 2 times lambda t power goes to 0 when t goes to infinity, which matches our expectation as well. Rt1 and t2 equals e of negative 2 times lambda times the absolute value of t1 minus t2 goes to 0 when t1 minus t2 goes to infinity. That matches our common sense when T1 and T2 are far away. Xt1 and Xt2 are less correlated. Next one, random telegraph signal. Yt equals A xt. P of A equals 1 equals P of A equals minus 1 equals half, where xt is a semi-random telegraph signal. P of yt equals 1 equals P of yt equals minus 1 equals a half. This makes us guess that yt may be a strict stance stationary. E of yt equals constant also makes us guess SSS. Then random talk. Toss a fair coin n times. K is the number of heads in n toss. X of nt equals ks minus n minus k times s equals 2k minus n then times s. From the probability methods, we guess that when n goes to infinity, we will have Gaussian density. The autocorrelation function contains a term minimum of T1, T2, which comes from the property of independent increments. Wiener process. Wt equals limitation xt when t is to 0, s squared over t goes to alpha, n goes to infinity, where xt is the random walk.